Hello. So this is going to be the Fall 2021 AMC 10B. Today we'll be solving problems 1 through 15. My name is Andrew. I took the 10B a couple days ago, and I'm a teaching assistant at Math Topia Academy. So let's get started. So we start off with problem 1. So it's asking, well, what is the value of this sum of four numbers? So it's just a sum of four-digit numbers, but you can save a bit of time by noticing the following. So for example, for the digit 1, it appears here, and then here, and then here, and then here. It kind of cycles, right? And the same thing happens for all the other digits. They're just staggered behind by 1, or ahead by 1, or like behind by like 2, right? So it looks like this, right? If I like color code all the numbers, you can see each one appears exactly once in each number and exactly once in each sum of places, right? So like 4, 1, 2, 3, 3, 4, 1, 2, 2, 3, 4, 1, and 1, 2, 3, 4. They all appear in the same place. So therefore, if we are adding all four of these up, then we just get here 10, here 10, here 10, and here 10. And if we add these all up, we get this, 11,110. So that would be choice E. All right. Moving on. Problem 2. What is the area of this shaded figure, right? So it's like this sort of arrow shape. So what I can see is that, well, we don't know the area of this, right? We don't have like any closed expressions that represent the area of an arrow, but we can divide it into triangles in more than one way. One way to do so is to draw this line. If we draw that segment, it'll divide it into this triangle, and they both have a base of 3 and a height of 2. So the area would be this, right? 3 times 2 over 2 plus 3 times 2 over 2. So 3 plus 3, which is 6. And the other way to solve it would be, if we didn't have this line right here, well, what we could also do is we could draw in this segment, and then notice it would just be the area of this big triangle minus the area of this tinier triangle, right? That would be the other way to find the area. And those two triangles have areas of 4 times 5 over 2 and 4 times 2 over 2, respectively. So we get 10 minus 4, which would give us 6. All right. So we know our answer is 6, B. All right. All right. So problem number 3. So we have this expression 2021 over 2020 minus 2020 over 2021, and it's equal to this fraction in which the numerator and denominator are relatively prime, and it's asking for what the numerator is. All right, so basically what I immediately notice is that we can have some canceling. So 2021 over 2020 is just this number, right? It's just 1 20/20th over 1. And this number here is just 1 20/21st minus that, right? Because the numerators, if we multiplied them right now by 2021 or 2020, right, in order to get a one common denominator, is going to be messy. So we can just express these in terms of 1, and then we'll just cancel, and we'll end up getting this. So actually that difference is just equal to this sum. So now we just have the sum of these two fractions, two inverses of two consecutive integers. So now we're wondering what would be the least common multiple between these two numbers, right? In order to get a fraction that's in which the numerator and denominator are relatively prime with each other. Well, any two consecutive numbers, right? They're always going to be relatively prime because any number that would divide both of them would also divide their difference. And in this case, their difference is 1, right? Which means the number could only be 1. So no number bigger than 1 divides both of them. Therefore, the least common multiple of them would just be their product. So we can multiply this fraction by 2021 over 2021. and multiply the other fraction by 2020 over 2020 in order to get this. And then we'll just end up with the numerator being 4041. All right. Problem number 4. On noon on a certain day, Minneapolis is n degrees warmer than St. Louis, right? And then at 4 o'clock, the temperature in Minneapolis has fallen by 5 degrees, while the temperature in St. Louis has risen by 3 degrees, at which time the temperatures in the two cities differ by 2 degrees. All right. So what is the product of all possible values of n? Well, here's Minneapolis, right? Here's St. Louis. So here is noon, and then here is 4 o'clock. So at noon, the temperature in Minneapolis, at noon, the temperature in Minneapolis is n degrees warmer than St. Louis. So St. Louis might have x, but Minneapolis would be x plus n. And then at 4 o'clock, the temperature in Minneapolis has fallen by 5, and the temperature in St. Louis has risen by, well, not just x, has risen by 3. So therefore, it's just saying the temperatures in the two cities differ by 2 degrees. However, notice it doesn't say which one is the warmer city. Therefore, we subtract these two. So this number minus this number, but we take the absolute value because the difference between these two could be 2 or negative 2. So if we do this, we get some canceling. That just results in n minus 8. So the absolute value of n minus 8 is equal to 2. So that means n minus 8 is equal to 2, or n minus 8 is equal to negative 2, right? So in this case, right, n would be equal to 10. And in this case, n would be equal to 6, right? So therefore, the product of all possible values would just be, of n would just be 10 times 6, which would give us 60. C. All right. Problem number 5. So n is 8 to the power of 2022, which of the following is equal to n over 4. So basically, it gives you a bunch of these different exponent thingies, but they're each in different powers of 2, right? So some of them have 2, some of them have 4, some of them have 8, and it's all just trying to confuse you. So what you should do is you should just convert this into a power of 2, right? So let's convert it into a power of 2. It would just give us 2 to the power of, well, notice 8 is just 2 cubed. So we would get 2 cubed to the power of 2022. And then by exponent rules, we can just multiply these two to get 2 to the power of 6,066. So 2 to the power of 6,066. And now dividing by 4 is just dividing by 2 squared, which means we subtract 2 from the exponent, right? So now we have to figure out, okay, well, there's answer choices here that are powers of 2, 4, and 8. So let's just equate this to powers of 2, 4, and 8. So for power of 2, we already have 6064. For power of 4, all we have to do is divide this by 2 to get 3032. And then notice for 8, we have to divide this number by 3, but it doesn't even divide 3 evenly. And the exponents here are all integers, so that wouldn't work. So these are the only two forms that could be on it. And sure enough, the only one that is actually on it is E, 4 to the 3032. All right. Problem 6. So the least positive integer with exactly 2021 distinct positive divisors can be written in the form m times 6 to the power of k. All right. And it's asking, what is m plus k? So basically, the formula for calculating a number, so like let's just say, for example, that number is p to the x times q to the y times r to the z. Let's say this is our number, right? Well, then the number of divisors of n would be, well, we take each of the exponents and add 1. And this is pretty simple to explain, right? For each of these prime powers, in order to form a divisor, we could choose, so for the p to the x term, the number of p's we choose could be 0, 1, 2, all the way up to, we could choose x p's. So from 0 to x would be x plus 1 different ways to choose the number of p's. And then same thing for q and r. So this can be extended to any number of exponents, right? In this case, there's exactly 3. But if there were 4, let's say there was a new term like s to the w, then we would just add on w plus 1 to it, right? So really, we could either have, right, n could be a number, p to the power of 2020, right? Because in that case, we would just add 1 and get 2021, right? But obviously, even if we set p to the smallest prime number 2, 2 to the 2020 is a huge number. Like, I'm talking really big. So that's definitely not going to cut it. We're going to need to find a different number for this scenario. And what we can do is we can find 2021 and break it down into 2 factors, right? 2021 can be divided into 43 and 47. 43 times 47 is equal to 2021. And notice these are both prime. Therefore, we cannot break them down any further than this. So the most number of prime exponents that can be had is just 2, right? 1 to make 43, 1 to make 47. So in this case, n would be p to the power of 43 times q to the power of 47. Or no, it would be x would be p to the 42 times q to the power of 46, right? So the way to minimize this, obviously, is to pick the smallest number first, right? And then pick the next smallest number for the next smallest exponent, right? 2 to the 46 times 3 to the 42. Because the other way around, if we chose like this, right, it would obviously be bigger, because here there'd be an extra 4 3s instead of an extra 4 2s. So we arrange them like this. And this becomes, well, if we express it in the form we want, right, this just becomes 2 to the 4 times 6 to the 42. So 16 times 6 to the power of 42. So we get that m is going to be 16, our k is going to be 42, and our answer of m plus k is just equal to 16 plus 42, which is 58. All right. Moving on. Number 7. Problem number 7. So we call this fraction a over b special if a and b are positive integers whose sum is 15. All right. How many distinct integers can be written as the sum of 2, not necessarily different special fractions? All right. So basically, if we write out all the fractions, right, like we'll see that there's a total of 14 of them, right? From 1/14 to 14, right? So at first it might seem like, oh, we need to do every single pair of them and add them together to see if it makes an integer. However, there is a shortcut that we can use in order to save a ton of time in this problem, right? And that is the fact that if there's 2 fractions, right? 2 fractions that add up to an integer, right? Then the denominators of these 2 fractions have to be the same number in simplified form. So if we simplify both fractions, their denominators have to be equal if we want to make their sum an integer. That's the only way to make their sum an integer. So the reason for this it isn't too complicated, right? So let's say n is our integer, and a over b, where a and b are relatively prime, is one of the fractions, right? If we do n minus a over b to figure out the other fraction, we get nb minus a over b, right? And notice nb is a multiple of b, meaning nb contains every single factor that exists in b. And then a is a number relatively prime with b, right? It is not divisible by any of b's factors. For any factor b, a has a non-zero remainder with it, right? So by subtracting off a, we are effectively stripping nb of every single possible factor it has that in common with b. Therefore, nb minus a will be relatively prime with b. And because of this, this fraction is unsimplifiable, in addition to this one already being, because a and b are relatively prime. Therefore, both fractions have to have the same denominator. So let's just write out the fractions. So we have 1/14, 2/13, 3/12, but 3/12 is just 1/4, right? We have 4 11ths. We have 5 tenths, but 5 tenths is just a half. We have 6 ninths, but 6 ninths is just 2/3. We have 7 eighths. We have 8 sevenths. We have 9 sixths, which is just going to give us 3 halves. And then we also have 10 fifths, which is just going to give us 2. And then we also have 11 fourths, which is just going to pair up with this 1/4 we already have. And then we have 12 thirds, which is just going to give us 4. And then we have 13/2, which is just going to go up here with the other halve numbers, right, with a denominator of 2. And then our final number is 14/1, which is 14, right? So I organized these by denominator because of what we said before, in that only two numbers with the same denominator can be added to make an integer, right? So basically, for each of the categories where there's only one number, we can just add it to itself, right? Because notice, right, it says that the two numbers that we sum in order to get an integer, they're not necessarily different. They can be the same number. So for example, 1/14, right, plus 1/14, that gives us 1/7, but that's not an integer. So 1/14 is out. 2/13 plus 2/13, that gives us 4/13, but that's not an integer. 4 11ths doesn't give us an integer, doesn't give us an integer, doesn't give us an integer, doesn't give us an integer. All right, so we get rid of those via that method. So now moving on, we have these three categories. So I'll start with 1/4 and 11/4. So for the 1/4, 11/4 category, what we end up getting is, well, we could add 1/4 to itself, but that just gives us 1/2, which isn't an integer. 11/4 we could add to itself, but that would just give us 11/2, which also isn't an integer. So that wouldn't work either. However, we can use one of each. So 1/4 plus 11/4, and that would just give us 12/4, which is just 3. So that's the first one that ends up working. All right, and then we can just get rid of these because there is no way to make a different integer using them. So for the next category, we have 1/2, 3/2, and 13/2. Well, we can add 1/2 to itself to get 1, add 3/2 to itself to get 3. However, like we already said, we already got 3 from 12/4, so we don't need to write it again. And then 13/2, if we add it to itself, we get 13. And then we can add them like by pairs. So 1/2 and 3/2, if we add together, we get 2. 1/2 and 13/2, if we add together, we get 7. And then 3/2 and 13/2, if we add together, we get 8. So we get those 5 from these three. And then finally from 2, 4, and 14, well, 2 we could add to itself to get 4. 4 we could add to itself to get 8, but we already have an 8, so we are not going to do that. And then 14 we could add to itself to get 28. And then we could do the pairs. So 2 and 4, if we add them as a pair, we get 6. 2 and 14, if we add them as a pair, we get 16. 4 and 14, if we add them as a pair, we get 18. So we get all these different numbers, and in total there is 11 different ways. All right. Number 8. So the greatest prime number that is a divisor of 16,384 is 2, because 16,384 is 2 to the 14. So what this is saying is, okay, so we're looking for the greatest prime number that is a divisor of 16,384, but it only has 2's. All it has is the smallest prime factor, 2, right? So therefore, since there's no bigger prime factor in it, 2 is the greatest prime number that divides it, right? And then saying, what is the sum of the digits of the greatest prime number that is a divisor of 16,383? Well, 16,383, if you didn't already know, is just 2 to the 14 minus 1, right? From what was just said in the previous sentence. And now we can use difference of two squares in order to get that this is equal to 2 to the 7 plus 1 times 2 to the 7 minus 1. And in the case of this, right, we can just find it, right? We can find both numbers because they're just 3-digit numbers. 2 to the 7 is 128. So we just get 129 times 127. And from here, we can fully factorize the number. Because for 3-digit numbers, right, it's not too hard to check. Since both of these numbers, right, they're under 13 squared, we only need to check their divisibilities from 2 to 11, right? So we check for 129. Well, it's divisible by 3, and we end up getting 3 times 43, right? And then for 127, we check 2, doesn't divide it. We check 3, doesn't divide it either. 5 doesn't divide it. 7 also doesn't divide it. And then we get to 11, and 11 also doesn't divide it, which therefore means that 127 is actually a prime number. So the greatest prime number that is a divisor of 16,383 is just 127. And if we add up the digits, 1, 2, and 7, we get our final answer of 10, C. All right, number 9. So this one is a bit of, this one's a little bit hard to figure out, but don't worry, it's not too bad. So the knights in a certain kingdom come in 2 colors, right? 2/7 of them are red, and the rest 5/7 are blue, right? Furthermore, 1/6 of the knights are magical, right? And the fraction of red knights who are magical is 2 times the fraction of blue knights who are magical, right? What fraction of red knights are magical? So let's try to figure this out. Well, let's say that the fraction of blue knights who are magical is n, right? That's the fraction of blue knights that are magical. Well, that means the total number of blue knights that are magical is 5/7 times n, right? Because n is the fraction of the blue knights, and blue knights is already just 5/7. So this is the fraction of total knights, right, that are magical. And then we'll add this to, well, what is the fraction of red knights that are magical? Well, this is just, 2/7 times, and then 2n, right? Because 2n is the fraction of red knights that are magical, because it's 2 times the fraction of blue knights that are magical, and we're multiplying it by the 2/7 we already have. So therefore, what this sum needs to be equal to is 1/6, right? So it's just a simple equation. Obviously, this is very confusing. The means of attaining the equation is a bit complicated, but in reality, this is what the problem boils down to once we put all these words into this. So now we can just solve. It's not too difficult. We multiply by 7. So 9n is equal to 7/6. So we'll just divide by 9 and get 7/54. So the fraction of red knights that are magical will be 2n, right? That's what we're looking for. And that will just give us 7/27. C. All right, number 10. So this one is like, the classic AMC, like MAA, just putting a logic puzzle on the test instead of an actual math problem. So it goes as follows. Here's the logic puzzle. So 40 slips of paper, numbered 1 to 40, are placed in a hat. So Alice and Bob each draw one number from the hat without replacement, keeping their numbers hidden from each other, right? So the problem doesn't say this, but of course, from their conversation, right? They just say like 2 words each, and then they each know each other's numbers. Well, basically they both have perfect logic, right? So Alice says, I can't tell who has the larger number, right? And then Bob says, I know who has the larger number, right? And then Alice says, you do, is your number prime. Bob says yes. Alice says, in that case, if I multiply your number by 100 and add my number, the result is a perfect square. So this conversation, obviously, we'll start simple. We'll start with the first sentence. So Alice says, I can't tell who has the larger number. So what does this mean exactly? Well, that means that Alice does not have the least number and does not have the greatest number, right? Because if Alice had 1, then she would be able to tell, oh, Bob must have 2 through 40. Therefore, Bob must have the greater number, right? That's what she's thinking, right? But then she says she can't tell. And with 40 as well, she would be able to tell Bob has the smaller number. She has the larger number, right? Because 40 is the largest number, right? So she can't have either of these numbers, which means she can only have a number from 2 to 39. And now Bob has this information. Bob has the information that her number is neither 1 nor 40. It has to be a number from 2 to 39. So now Bob says, I know who has the larger number. So from what we've just said, this must mean Bob has either 2 or 39, right? Because now he knows who has the larger number. And Alice is like, oh, you do? Is your number prime? Bob says yes, which means the number isn't 39 and is indeed 2. So this is the number Bob has. And Alice says, in that case, if I multiply your number by 100 to get 200, and then add my number, so I'll just denote Alice's number with A, then this number has to be some perfect square somehow. Well, A is just a number from, remember, A is just a number from 1 to 40, but we already know it's not 1, it's not 40. Bob's number is 2, therefore it's not 2. So A is just going to be some number from 3 to 30. Well, 39 is still an open possibility, right? A can be a number from 3 to 39, right? So, but there's only one perfect square in this range, right? So, because 14 squared is 196, which is too small, and 16 squared is 256, which is too big because the most we can get to is 239. So the only one that would work is 15 squared, which is 225. Therefore, we get, oh, A has to be 25. And now the two numbers we know have to be 25 and 2, and the sum of them is just going to give us 27. All right. Problem 11. All right, so this one is a geometry one, and it's not too difficult. So let's just work on this one. So we have a circle here. Let me just make it a bit thicker so everyone can see it. All right. So we have this. So we have a regular hexagon of side length 1 is inscribed in a circle. So let's inscribe it inside there. Let's draw in those sides. Get it in nice and neatly. All right. So here's our hexagon. And we have that each of its side lengths are 1. And it says each minor arc of the circle determined by a side of the hexagon is reflected over that side. So this will be a bit hard to draw. Hopefully I can get it to look okay. So we reflect each of these tiny little arc length pieces over, right? So it's saying, what is the area of the region bounded by these 6 reflected arcs? So if C is the area of the circle and H is the area of the hexagon, how can we express this area, right? The area inside each of these little like nooks and crevice, right? Each nook and crevice of each of these like curves, right? So how can we decide what this area is, what the stuff in the middle is? Well, the way we can decide it is, well, what is the area of each of these tiny arcs, right? The area of the sum of all 6 arcs, well, that's just C minus H, right? If we take the area of the circle and subtract the hexagon, we just get those 6 tiny little arc pieces. We get this piece, and 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 this piece, right? And now what we're doing by reflecting them into the hexagon and finding that new area is we're taking the hexagon and we're subtracting the area of those 6 arc pieces. So we're just doing this, which ends up simplifying to 2h minus c. So what we're actually looking for is 2 times the area of the hexagon minus the area of the circle. And that's not too difficult to look for. So the area of the circle, because the side length is 1, and by simple like 60-degree angles, right? 1, and then this is a 60, 60, 60 because it's an equilateral triangle. So the radius is just going to be 1. So the area of the circle is pi, and then the area of this triangle here is just going to be root 3 over 4 times 1 squared, which is just going to give us root 3 over 4. Then we can multiply by 6 to get the area of the hexagon in full. And the area of the hexagon in full is just 3 root 3 over 2, right? And then 2 times 3 root 3 over 2 minus pi to give us a total of 3 root 3 minus pi as our final answer. And sure enough, that is marked as B on the answers. So that's our answer. All right. Moving on, we have problem number 12. So it's asking, which of the following conditions is sufficient to guarantee that integers x, y, and z satisfy the equation x times x minus y times plus y times y minus z times z minus x equals 1? Well, now here's the thing, right? This equation here is much more complicated than you think. And actually, none of these describe the equation none of these describe all of the solution sets, right? Like, what do I mean by this? What I mean by this is, that like x, y, and z, right? If we like plotted this function on a 3D graph, it would be this whole mess, right? Of like a lot of curves and stuff in this like beautiful pattern, right? None of these are that. All of these are like linear relationships. All of these will just take a singular curve on it, or a singular line, or a singular plane, right, on the whole mess of it. So there is no point in trying to solve this. What we should do instead is we should use the fact that we are given answer choices and just try plugging in values and see what works. All right, so let's try that. Well, notice whenever it says two numbers are equal to each other exactly, they cancel, right? Because we have minus and minus in some of these, right? So what we should try to do is, as much as possible, we should try to either set a number to 0, or we should try to set two numbers equal. Because if we can do one of those two things, a lot of stuff will cancel. So for example, for A, right? Well, x is greater than y and y equals z. Well, if y equals z, then this part is just 0, so that term goes away, and we're just left with x times x minus y plus z times z minus x, and y is equal to z. So like, I do this, right? X squared minus yx plus z squared minus zx, right? And then y equals z. So I just like, this zx becomes yx, right? And then this z squared becomes y squared. And then we just get x squared minus 2xy plus y squared, right? And that will give us, right, x squared minus 2xy plus y squared, x minus y squared, right? But the problem is, it doesn't specify what x minus y is. For example, if we just set, like, for example, y to like 1, z to 1, and we set x to 3, in the end, we'll just get 2 squared, which is 4, right? You can plug these back in and try it, right? 3 times, and then 3 minus 1, 2, plus y times y minus z would give us, this is a 1. It's just, I drew it very badly. 1 times 1 minus 1 is 0. Plus, and then z times z minus x would just give us -2, right? We just get 6 minus 2, which is 4, just like we predicted here, right? It's not 1. So therefore, since there is a solution to A that does not satisfy the original equation, A is out, right? And we can continue this onward. Let me just like erase all this. All right. So it's not A. And then we can continue like this. We can try D, right? Because D also specifies two are equal, right? But then it also specifies this. So that one makes that this one has a lot more opportunity, because like I just said before, right? If we do everything the same way we did before, right? Now we just have x equals z, but this equation is symmetric, right? So having x be z also makes one of the terms become 0, and then the other part becomes this, which becomes, right, plus, but then x is z. So we can just plug in x here in replacement of z to get that. And then we just get, when we do this, x squared minus 2xy plus y squared, right? But now notice in this case, we are told y minus 1 is x, right? So we are told y minus 1 is x, which means in this case, right, if we do it the other way, y minus x is 1 from this, and x minus y is -1. So we plug in -1, and sure enough, we get 1. So it'll always be equal to 1. So D is actually the correct answer. We can go through the other ones, right? It's not too hard to see the other ones don't work, though. Like, for example, for B, we could try, well, x is 2, y is, well, yeah, we could try x is 0, y is 1, and z is 2, right? Like if we tried that, this would cancel, right? And then the other two terms would just become 1 times 1 minus 2, -1, and then the next term would just become 2 times 2, 4, right? This is 3, that's not 1. So B doesn't work. For C, for example, we could try z is 0, x is 1, right? And y is 2. And for what we just said, right, this equation here is symmetric. So any permutation of 0, 1, and 2 will fail. So this one will also fail. And then in the case of x plus y plus z is 1, right, we could just set all of them equal to 1. No, we could set them all equal to 1/3. And that would make all three of these terms equal 0, right? We would just make all of them instantly equal 0. And in that case, the sum would also just be equal to 0. So E doesn't work. So our answer is D. All right. All right, so number 13. So we have a square with side length 3 here, and a square with side length 2 here. So here we would have like 1/2, 1/2, 3, 3, 2, 2, 2. And actually, I don't like this diagram because it's misleading about this ratio, right? Because this is 2, this is 1/2, but this looks like a 2-to-1 ratio. So I'm just going to redraw this in a way that looks much more realistic. So like, let me just pull that out. Yeah, let me just go like that. There we go. All right, so let's make it green. Wait 1 second. Make it side. Okay. All right, so we have a square, and then a length 2 right here. Be like about that much. All right, so this looks much better, and it's a bigger diagram, so it's good as well. So if we draw in this line, yeah, it's like goes up like that and comes down like this, but it's like we don't need to see the tip of it anyway. So, right, we have 2 here, we have 1/2 here, 3 here, 3 here, 1/2, and 2. So by similar triangles down here, right, 2, 1/2. Well, since here is 3, it's just 1/2, but this triangle here, right, is similar to this one. So it's just scaled up by a factor of 3/2. So 3/2 times 1/2 will give us 3/4, right? And then over here, same thing, 3/4 here, down here, 3, right? And now we have this height here is 3. This height here is 2. And then notice here we have a base of 2, right? So we can use similar triangles here as well. So in this case, right, the base here is 3, right? And the base here is just 2. So, and this difference, the difference between the heights is 2, right? So if this is 3, so the ratio of this is 2 to 3, right? So that means this here is equal to 1/3 of the entire height, 2, right? So therefore, this length here would be 4 in order to make this 6 and make the whole ratio 4 to 6, right? So this height here, it goes off the screen, but we don't need to see it. This height goes up to 4, right? And this is, we can also see this from drawing an altitude from the vertex. If we draw an altitude, then it's similar once again, and this is 2, 1/2, 2. And then right here we have 1 and 1. So it's a ratio of 1 to 4. We can do that as well. And we, once again, 1 to 4. So this would be a 4. So 2 ways to find it. The altitude is 4. So the total area of the entire triangle would be, the height is 4 plus 2 plus 3, which gives us 9. The base is 3/4 plus 3 plus 3/4, which gives us 9/2. So the area is just going to be 9 times 9/2 over 2, which is going to give us 81/4, which is 20 1/4. So that would be answer choice B. All right, number 14. So we have Una. She rolls 6 standard 6-sided dice simultaneously and calculates the products of the 6 numbers. So these 6 numbers, well, it's asking what is the probability that the product is divisible by 4, right? So for example, her rolling a 1 and a 3, those mean the exact same thing to her because neither of them contribute a factor of 2, right? So in reality, we can just change it from 1, 2, 3, 4, 5, 6. We can just change that to 1, 2, 1, 4, 1, 2, right? Because those are the factors of 2 present in each of them, right? And we're only worried about divisibility by 4, which is multiple factors of 2, right? So basically, what is the product that the product is divisible by 4? Well, let's think, what is the probability that the product is not divisible by 4, right? Well, there's only 2 ways this can happen. Way 1, we roll 1, 1, 1, 1, 1, 1, right? All 6 in a row, right? Or the second way is we roll 1, 1, 1, 1, 1, 2. If we roll anything other than this, If we roll more than 1, 2, it's going to give us a 4. If we roll a 4, it's going to give us a 4. So these are the only two ways to do it. So in the case of 1, 1, 1, 1, 1, 1, each one has a 50% chance of happening, right? So for a total of 1 out of 64, right? And then for this case, well, we can choose the 2 to be anywhere we want in any of 6 locations, right? We can have it in the first, second, third, fourth, fifth, or sixth spot, right? And in any one of the six-sided dice. But then the product of this happening is just 1/2 to the power of 5. It's just 1/2 to the power of 5 times a third, which is 1/32 times 1/3, which is 1/96th, right? 1/96th. So that just becomes 1/16th, right? So basically, the probability that the product is not divisible by 4 is just the sum of these, which is 5 over 64. Therefore, the probability that the product is divisible by 4 is 1 minus this, which is equal to 59 over 64. And that would be answer choice C. Right, 59 over 64. Nice. All right. All right, so back at number 15. So we have this square, and these points P and Q, and these two segments, right, they intersect to form this right angle. So obviously this right angle could lead to all sorts of like things with Pythagorean theorem and stuff if you wanted to bash the problem, but we're not trying to go for that. So let's try some angle chasing using that angle instead. So if we call this angle alpha, we have this is the right angle, 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 this is the right angle. We have a lot of right angles, and we also have a lot of alphas, like this angle right here is alpha. And from this angle alone, we can see, well, let's take a look at triangles CQB and triangle BPA. So from these two triangles, right? Well, they share this congruent angle. They share these two congruent angles, and they share this side and this side of a square. And squares, they have equal sides. So by ASA, these two triangles are congruent. And this is most important in showing CQ is equal to BP, right? CQ is equal to BP, and BP is just 13. So therefore, CQ is 13. And the other thing this shows is triangles RQB and BQC are similar, and or a different set that's more useful. BRQ, triangle BRQ is similar to triangle CRB, right? And from this, we can get the following. BR over RC is equal to QR over RB. And RB in this case is just 6. So we cross multiply. 36 is equal to QR times RC. I'll just plug in. This is X. This is Y, right? X is obviously less than Y. And 36 is just going to be X times Y. So we have that. And then also X and Y are the two sides that make up CQ. So X plus Y is going to be 13. So now we have the system of equations. XY is 36. X plus Y is 13. And we can create a quadratic and solve this, right? But you can also see right away, you can almost definitely see right away what the solution is. But we can just create a quadratic from this by the following. X is 13 minus Y, and then 36 is Y times 13 minus Y. And then we just get Y squared minus 13Y plus 36 is equal to 0. And then if we factor this, we'll get this. Y minus 9 times Y minus 4 is 0. So Y is 9 or 4, right? And X is also 9 or 4, right? They each take each other's places, right? But we can see from the diagram that because BP is on AD, right? That means that this segment here has to be less than this segment here, right? Because if we had it like this, right, and like this, the two segments would be equal, right? But as it becomes more and more close towards A, right, it cuts it off at tiny ratio, right? So X is going to be smaller than Y. So x is going to take 4 and y is going to take 9 because angle PBA is by necessity less than 45 degrees, right? So x is 4, y is 9, and now we can find the area of the square because knowing that's 4 and that's 9, we can do many things. Probably the most simple, just using Pythagorean theorem here on the 6 and the 9, in order to get, well, BC squared is just equal to 9 squared plus 6 squared. We don't even need to solve for BC because BC squared is just the area of the square, which is what we're looking for. So our answer is just going to be 81 plus 36, which is going to give us 117, and that is our answer, choice D. All right, so those are the solutions to problems 1 through 15. So yeah. All right, so those were the solutions to problems number 1 through 15.